What if I told you the farthest planet in our solar system has winds faster than a fighter jet, storms that appear and vanish in years, and a moon colder than liquid nitrogen? Meet Neptune. I reckon most of you probably won't recognize this at first glance, but this is likely the first time you're really having a proper look at it. I'm going to give you the full rundown on this blue beauty. If the Uranus content felt like basic stuff to you astronomy veterans, Starweaver hopes you'll help answer questions in the comments for everyone else. Whether you're new to this or not, buckle up. Today I'm taking you on a journey to Neptune. Neptune is the farthest planet in our solar system, sitting a whopping 4.5 billion kilometers from the Sun. And yep, it's completely blue and absolutely stunning. While light takes just 8 minutes to reach Earth, it takes over 4 hours to get to Neptune. You might think it's too far away to matter to us, but honestly, its story is way more exciting than you'd imagine. How big is Neptune? If Earth were a 1 centimeter glass marble, Neptune would be about the size of a ping pong ball. Pretty massive, right? It's 17 times heavier than Earth and 58 times larger by volume, but much less dense at just 1.64 grams per cubic centimeter. Don't let the size fool you though. Neptune's mainly made up of hydrogen, helium, and methane, making it a gas giant like Jupiter and Saturn. But scientists prefer calling it an ice giant along with Uranus because they've got heaps more water, ammonia, and methane ice mantles. We covered the specifics in the Uranus episode, so I won't bang on about all that again. Neptune's blue color is absolutely stunning. You might think it's blue because of water like Earth, but actually it's due to methane in its atmosphere. Methane soaks up red and orange light while reflecting blue and green light, giving Neptune that deep, brilliant blue we see through telescopes. Its name comes from the Roman god of the sea, Adaxnot. Pretty fitting for its appearance, don't you think? Neptune's discovery is a fascinating story. Back in 1846, scientists noticed something dodgy about Uranus's orbit. After some serious mathematical number crunching, French mathematician Leverrier and British mathematician Adams boldly predicted Neptune's existence. German astronomer Gall then used their calculations to actually find the planet with a telescope. That makes Neptune the first planet in human history discovered through maths, rather than just spotting it in the sky. Shows you how important it is to study maths, right? Neptune spins incredibly fast. One rotation takes just 16 hours. While Earth completes one rotation, Neptune does 1.5. Fair dinkum fast. Its axial tilt is 28.3 degrees, similar to Earth's, so it technically has seasons. Because of its low eccentricity, seasonal changes aren't as dramatic as Earth's, but they exist in theory. The catch? Each season lasts over 40 years because Neptune takes 165 years to orbit the Sun once. Imagine that. One Neptune year and several generations have passed on Earth. It's like time moves at completely different speeds. Temperatures are bloody cold, with the upper atmosphere averaging around 214 doubles. That's colder than anything you'll find in your freezer. Yet, in this freezing environment, Neptune hosts the most violent storms in the solar system. Wind speeds can reach 100 kilometers per hour, more than 5 times stronger than Earth's hurricanes. Here's the kicker. Even if you were running at bullet train speeds with the wind behind you, these gusts would still send you flying like a rag doll. Scientists have always wondered, how can Neptune, so far from the Sun with bugger all energy input, generate the most ferocious storms? The answer might lie within. Neptune actually releases more heat than it receives from the Sun. Internal heat convection makes the atmosphere churn like boiling water, with storms constantly erupting. For Neptune exploration, humanity has only sent one probe, Voyager 2. Back in 1989, Voyager 2 flew past Neptune, our only spacecraft to ever visit this distant world. It sent back incredible photos and data that revealed Neptune's Great Dark Spot, similar to Jupiter's Great Red Spot, a massive cyclonic storm. What's really interesting is that this dark spot disappeared within a few years, showing how dramatically Neptune's atmosphere changes. Storms can form and vanish in surprisingly short timeframes. Talk about unpredictable weather. Besides the dark spot, Neptune has extremely faint rings. They're not as spectacular as Saturn's, but equally mysterious. The rings are mainly dust and tiny ice particles, with some showing uneven brightness distribution called ring arcs. How these arcs form remains a mystery, possibly related to gravitational effects from Neptune's moons. Scientists are still scratching their heads over this one. Speaking of Neptune's moons, that's another highlight. It has 14 known moons, with the largest being Triton. This one's absolutely fascinating. It's the only large moon in the solar system with retrograde orbit. meaning it orbits opposite to Neptune's rotation direction. Scientists reckon Triton was originally a Kuiper Belt object captured by Neptune's gravity. Triton's diameter is 706 kilometers, A5's larger than Pluto. Surface temperatures drop to 235 degrees C, nearly absolute zero, yet it has active geology including nitrogen geysers. Yes, you heard right, ice volcanoes. They don't spew lava but liquid nitrogen and dust, reaching heights of 8 kilometers. That's the same liquid nitrogen they used to freeze the T-1000 in Terminator 2. Pretty cool, eh? Beyond Triton, Neptune has heaps of smaller moons like Nereid and Proteus, each with different orbits. Some orbit close to Neptune, while others circle from great distances. These moons have complex gravitational relationships with Neptune's ring system that scientists are still trying to figure out. Neptune's magnetic field is a beast, incredibly powerful, with the magnetic axis tilted 47 degrees from its rotation axis. Compare that to Earth's 11-degree difference. That's way more extreme than Earth's. This extreme magnetic structure creates unique aurora phenomena. Scientists have observed through telescopes that Neptune's auroras form brilliant light bands in its atmosphere. While not as easily visible as Earth's auroras, they're equally impressive under scientific instruments. Neptune's discovery expanded our understanding of the solar system. Beyond its orbit lies the mysterious Kuiper Belt, home to countless icy objects including Pluto, Haumea, and Eris. You could say Neptune is the guardian of the 8 planets, helping us understand our solar system's structure. Neptune isn't just a guardian, it actively influences the entire solar system. Heaps of Kuiper Belt objects change orbits due to Neptune's gravitational pull. Some get flung into the inner solar system, so that meteor you see might be visiting Earth thanks to Neptune's gravity. Neptune acts like a massive, cosmic coordinator, quietly maintaining solar system order. From Mercury to Neptune, we've witnessed humanity's journey exploring the universe. This blue beauty has only been visited once by Voyager 2 in 1989, leaving us with stunning imagery and incredible data. Future missions are already being planned to unlock more secrets of these ice giants. With advancing technology, we might soon visit Neptune and its moons, perhaps even turning the Neptune system into another stepping stone for deeper space exploration. The mysteries of the outer solar system await us. Neptune, with its violent storms, mysterious rings, and fascinating moons, reminds us that even in the coldest, most distant corners of our cosmic neighborhood, there's still so much to discover and understand. This is Cosmic Canvas. I'm Star Weaver. If you love space exploration and cosmic mysteries, hit that like button and subscribe. We've completed our journey through all 8 planets. What an incredible ride. Next, we'll explore the dwarf planets, asteroids, and other fascinating objects in our solar system. Don't miss it. See you next time. Love you all.